Hello, everyone. My name is Faris Kandakji. I work for Intel in Hudson, Massachusetts. I've been in the stimulus business for about 14 years, give and take. And I've got a kind invite from the Accellera board to give you an update on our portable stimulus work group. This is pretty much an awesome work group that started in 2014. And we started as a proposed work group to discover the problem space, and we collected a lot of requirements, about 120 requirements, with a lot of momentum, a lot of interest from user companies and vendors, and technology providers. And at the beginning of this year, it became an official work group, and we kicked off our activities back in March with DVCon. And I got to tell you, this group has been on a roll. It's been a fantastic group of folks. I really enjoy working with everyone, and it's coming to a very, very great set of goals and intent. So just we have just background information. I'm the chair. Vice Chair Tom Fitzpatrick from Intergraphics, and Tom Anderson. Without these two folks, I'd be really struggling to to move things along, given my day job. Like I said, we started out, kicked things off as a proposed work group back in 2014, and then we sensed and collected consensus that there is a real problem here, and it's a problem for many design houses and IP suppliers. Let's go solve it. Okay. So what we're talking about is this problem of being able to express stimulus and tests once for all platforms we run in. So that's one factor of portability. All execution platforms. We're talking about post-silicon, virtual platforms, simulation, emulation, FPGAs, and this is a real problem, right? We have, a lot of us who do chip design and products recognize that we have a lot of duplication of effort in the content creation, going from one environment or one platform to another. Sorry. Another axis of portability is the types of users that we're talking about. So you can, if you go in simulation, you have people familiar with UVM and UVM sequences and tests and system Verilog, etc. When you go up in the stack into emulation, you have a mix of folks doing maybe hardware verification type thing, or they're preparing their software early on. And then when you start going up the stack into post-silicon, you have a different set of folks with different set of challenges, and the environment is very different for them, and the languages they use and their methodologies are very different from what we're used to in simulation. I don't know why this keeps moving on its own, because I'm not moving it. And then we have the integration scope, which is how much is it you're targeting with your stimulus and tests? What is it that you're exercising and going after? Is it IP, hardware? Is it subsystem, collection of IPs, tightly coupled or integrated? Is it an SoC with both hardware and software? Or is it even up in the level of drivers and operating system and really testing the software stack that ships with the with the chips you're selling or the IPs you're providing? So that's another axis or factor of portability. And what we're talking about here is not creating a reference model. We're talking about creating a specification by which you can express this stimulus in a portable way, alongside some standard APIs to interoperate with the ecosystem. We realize we have an ecosystem around us of coverage, debug, and various things that we have to integrate in existing environments from different people that we need to integrate in. Okay? And the intent is to come up with that specification such that all the creativity and the R&D houses from the different vendors can offer us basically different different value propositions through their different technologies. From we took a stab at categorizing the requirements we looked at, so we're not walking through 120 requirements here, just giving you an idea of how we mapped out requirements. So on the right side, we call these portability goals. So, what the 4 factors I mentioned, the first one is, user and language portability across the different set of existing languages and users. The platform portability, the execution platform, the level of integration, how much we're testing, and then the configuration portability, which was not obvious on the previous slide. So given one product or one environment you're in, the same target could have multiple configurations. They could be random, they may not be random, it could be a mix, and we want to have portable stimulus across. Now, the real set of requirements that will drive the specification for the language in terms of syntax, semantics, and concepts is on the left side. And we broke the spec into these categories. So we have language, we have language-based requirements. We're talking about syntax and concepts. If you think of object orientation, encapsulation, these things are part of the concepts. When we talk about syntax, we talk about specific procedural flows or constraint-based flows and things like that. Then we have a set of, let's call them profiles or contexts in how we use this spec. So we have what we call use case-based verification, how we approach coverage and checking in the context of this portable stimulus and any requirements we have on that. Then there are visualization requirements, things that help you visualize what you've created, what you've, representing with stimulus. And then we have runtime, if I can read that correctly. Runtime portable semantics is extremely important as we move across platforms to make sure that you're observing and dealing with and debugging the same behavior. We're not talking about cycle accurate, consistency across platforms, but the algorithm you wrote or the scenario you expressed is running the same way across all platforms and across different vendor technologies. So we want to tighten up the spec to try to get to that consistency. Okay. Then we have a bunch of APIs to interoperate with the ecosystem. These will be staged in developments. This is a huge effort, guys. So it's not going to get done in 1 year or so. All right, things that we've been on a roll. We've set some milestones from the start. Yes, we've pushed some of these out in the process, but I think I participate in other work groups, and this is a very aggressive work group, and I really commend everybody to pushing on the time here. So we have the kickoff. We approved milestones objectives, and we have design objectives document we approved. We looked through the 120 requirements again and consumed any additional delta requirements that came from companies that joined us this year. We held the election for officers in June, and then we went through saying, okay, we have the requirements, we really need to make sure that there are supporting use cases and usage examples for these requirements. So the discussion can be, when we evaluate different contributions, can have a good caliber of, putting all the contributions on the same scale of measuring what they're covering, as opposed to a theoretical set of requirements. So we created 14 plus usage examples document, and we closed the call for contribution just mid-September. And this face-to-face, what we're here for this week, is to really dig into every one of these contributions and try to sense the best ideas from all, what the deficiencies look like, and try to have build some momentum for consensus about how we approach this in the rest of the year. The plan is to have a direction by end of the year, what technical path we're going towards, and that may be one contribution, maybe combination of contributions. We don't know that exact story yet. We are targeting a draft of the standard specification in mid-2016, and along with that is a release for I think for comments for everybody to look through. We have more timeline, stuff beyond this that are like every 6 months as well. Okay. A lot of good attendance, really. There's a huge interest in this problem. This week, we have 3 contributions from vendors. We have, one contribution that is, coming in with a new language, declarative language that has enough abstractions to help us go across platforms. We have another contribution that looks at it from a more point of view that is closer to what people are actually doing today in the different platforms, in the many different platforms in terms of C, C++. And we have another contribution from Viavia that is trying to emphasize, that's trying to augment any of the other contributions and add a standard interface between software and hardware, how we abstract the hardware in terms of device drivers, register accesses, memory accesses, and hardware attributes. I think that's it. So active members, these are, basically in bold, I think folks that are consistently there. We do have attendance from others that, are sometimes on and off, but I think the face-to-face at least records the companies in bold, and the rest of the companies are consistently on the call every week we have. So as you can see, there's a rather large mix of companies, and what's nice is a lot of user companies are behind this, and very collaborative attitude between the different vendors, because it's a big problem. That's all we have, and thank you again for inviting us.
Any questions for Faris? Okay, thank you, Faris.
Thanks.